This video is a collection of students' project presentations from the Digital Making and Learning class of 2023. Enjoy!
I'm a dance teacher and I have a lot of friends who are in school to become teachers or have jobs teaching kids. If you've ever been in charge of a large group of kids, then you know how challenging it can be to keep the noise level down at certain times. While in some classroom settings, it's encouraged for students to chat with their peers and talk about their ideas and opinions, there's other times that students need to have their own independent work time and be able to focus. It can be super frustrating as a teacher and other students and feel really chaotic when the classroom sound level gets too high. To solve this problem, I designed this box I like to call the quiet game. The teacher can turn it on and the sensor will sense when the sound level gets too high. When it reaches that point, a red light and a noise will go off, and then a different red LED on the side will go off and stay on too. This lets the students know that they are being too loud. There are 3 red lights on the side. The goal of the game is to not let all 3 of the lights go off by keeping the noise level quiet. This relieves some of the stress from the teachers and it helps the kids know exactly what the expectations are of them. It also helps to motivate the students by making it more of a fun game rather than just telling them that they need to be quiet.
Alright, the moment we've all been waiting for, the quiet game in action. The device is turned on and then there's a loud noise. It makes a little noise and the lights turn on, and every time there's a noise, one LED will go off until all 3 have gone off, and then the students know that they lost the quiet game.
Hi everyone, my name is Briston and I just want to show you my final project for my Digital Making and Learning class this semester. I decided to make a card shuffler, and the reason I chose this project was because my family likes to play a lot of card games and board games, and we only have one person in our family that knows how to shuffle. So I thought it'd be a good idea that we can build something that whenever we're playing games, everyone can shuffle.
Okay, so the way that I was able to design this is that I came up with 4 different options for our display screen. We're gonna go ahead and do the simple shuffle. I have a short circuit in one of my boards, so it won't fully work, but I'll just explain how it's supposed to work. So once you select which shuffle you're gonna want, you're gonna put all your cards right here in this loading bay. It will start to lower and then the cards will be split into either side of this main section. And then once they're all out of the loading bay, it will lower all the way down. And then these rotary turns will turn on, and then it will shuffle all the cards back into the loading bay. And then once all the cards are in here, it will raise back up. And then depending on which shuffle you decided, it will keep going or it will stop. Okay, so now I'm going to show you guys the more technical side of my project. This is ran off of 3 motors. We have a stepper motor right here, and this is in charge of moving this belt that will raise and lower my loading bay. And then we have 2 DC motors. There's one in this compartment right here, and then one in this bigger compartment down here. And one of the DC motors is what will split the cards into either side, and the other DC motor is what shuffles them back together into one. My whole project is ran off of this micro Raspberry Pi board right here, and then the way that it gets power is from this board that is all connected into a power outlet. And then to run the display screen, we have my buttons right in here. We've got the select button, a back button, and then a next button. Okay, so this was my final project for this class. The problem I was trying to solve was just building something that when we all get together to play games, that we can not have to rely on one person to come and shuffle all of our cards. So now that I have this project built, we can keep on playing at family game nights.
As a college student living with roommates, one of the biggest issues I face on the daily basis is doing laundry. Some of my roommates often leave their laundry either in the washer or dryer, and for hours or sometimes even for days. So it gets really annoying having to move their laundry every time I need to do mine. And I'm pretty sure that this is a common problem that people with roommates have to in general. So in order to alleviate this problem, I decided to make a laundry timer for my final project. So this is the laundry timer that I designed, and it's very simple to use. So the first thing that you want to do is to set your timer to your desired time by using the A and B buttons. You use the B button to add more time, like that, and use the A button to decrease it. Like that. And then 1 dot equals to 10 minutes. So if you have 4 dots light up like that, that means that you have 40 minutes set up to your timer. But for the purpose of this demonstration, I have set each dot to be just 5 seconds instead of 10 minutes, so we don't have to wait that long. To start the timer, you just have to press the A and B button together, like that. And then this light will turn on when the timer's running. The green dot means that we have 15 seconds left, and then 10 seconds, and 5 seconds. And there you go. So the alarm goes off, and then this sound will continue playing until somebody comes over and manually click the stop sound button. Like that. So the whole purpose of that is that so whoever's doing laundry will come and get their laundry as soon as it's done, because the sound just continuously playing. And then to set another timer, you just click the reset timer, and then you can just do the exact same steps again as we did just now. And then I also have detailed step-by-step instructions provided right here so that users can refer to this when they're using the product. And then I also have a suction cup thingy that users can use to stick this timer onto their washer or dryer. So that was my final project. Thank you.
This is my final project for my digital making and learning class. It is a reference to the video game Destiny, with inspiration from 801 from the Black Armory, as she also has lights that get brighter and dimmer as she talks.
You are not welcome here, Guardian.
The process took about 5 weeks of 3D printing, sanding, painting, filling, priming, and glossing, as well as assembly and software and hardware troubleshooting. As you can see, the LED eyes were intended to light up as well, but seems to be some sort of hardware issue. While this project does not solve any traditional problems, I believe that it does enrich my life, as I was looking for something to bring to a convention called FanX, and this is my solution. A big part of this assignment was to kind of challenge myself as a creator to see what I could make in a limited amount of time. Initially, my plan was to create something that I had already created, but I didn't feel sufficiently challenged by that, so I really wanted to stretch and leave my comfort zone. And this really did fill that need to learn and grow as a person.
Hey, how's it going? My name is Jackson Brady, and this is my project for the final project in digital making and learning. So I decided to make a toaster alarm for my project. So shown here is a picture of kind of the blueprint or prototype version of my toaster alarm kind of what it goes through. So it's in 3 steps. Step 1, as you can see at the top, is when nothing's activated, it's just sitting there. Nothing's lit up, it's just kind of chilling in neutral. Step 2 is when you push down the lever to cook your toast. So that's input 1. When you push down the lever, it's the lights on the circuit playground start doing a loading symbol or animation to kind of show that the toast is cooking. And then the 3rd step at the bottom is when the toast either pops up or someone clicks cancel on the toast. And that's when it'll pop up and activate an animation as well as a song to let the person know that their toast is done cooking. So here's the finished project or product. It's not completely done. I've had a hard time figuring out a way to connect the just the inputs to the circuit board. So for now I have buttons A and B acting as those inputs. So the first step 1, is when you push down the toaster. This popsicle stick is meant to touch this part of the scaffolding, I guess, and activate what would be the cooking animation on the circuit board. So that's what it looks like when the toast is cooking and it's pushed down. I don't have it plugged in right now, so that's why it's not pushed down. But when it would pop up, it would activate and hit this other piece of cardboard that would connect through conductive tape or whatever and activate an alarm with music and lights to let the person know that their toast is done cooking. So that runs through 4 times. I could change it so that it plays forever, so the person knows it's done cooking and they'll have to come turn it off, but that's kind of the idea I was going for. I didn't completely finish it, but I got the code and kind of the idea in the scaffolding up there. So the problem I was trying to solve is that people don't know when their toast is done usually, and there's an alarm on everything in the kitchen except the toaster. So that's kind of the problem I was trying to fix. And what did I make to address this problem was kind of just this. I made the scaffolding out of popsicle sticks, and then this little holder on the side for the circuit playground. And my target audience is just people who cook toast in the kitchen and just don't know when their toast is done, you know, because it gets stale or it just sits there forever. They just don't know. And I personally like it when my toast is hot so the butter melts on it when I spread it, you know. But yeah, that's my project. Hope you guys like it. I enjoyed making it, so thank you.
Hi, my name is Dakota Oldham, and I am excited to show you guys my final project. So for my project, I decided to do a cute little operation game. The problem that I wanted, or I guess the need I wanted to solve was you have some extra time and you wanted to play a game. But something specific to this game is that it is supposed to be my father. And so the audience is to be the grandkids and the children and people in my father's life that want to get to know him better. And so each of the spaces where there's an operation, they are places where my father had surgery. So like he got his knee replaced, he got his hip replaced, he broke both of his collarbones, so forth. And the fun part is that it works. And so let me show you. So I have these cute little buttons, little bee button, to put in the little pouch with it. You can't really see it, so I'm gonna put it down here. But you tap the little, you tap the cute little tin foil, and once you tap it, it's supposed to like beep. And so I'll show you guys the code afterwards. Sorry, it's very tricky, right? You have to be careful. So once you tap the tin foil, it's supposed to beep, and then the colors by his stomach, they light up. It's not a Mickey, but the piece that we are working with. So once you do that, you touch that, and it's the little, and I hope you guys can hear it. It's pretty quiet, but you play that, and you pick out a couple buttons. So you demoed the problem, the need. What problem are you trying to solve, or the need? Yeah. Let me show you guys. I have a little presentation. Share my screen with my finished product, but I had an issue with connection, so I fixed that. The little tweezers or the alligator clips, all I had to do was put the tinfoil around it, like the first image right there, and so it was a better connection. That's the process, and then this is the code. So once you touch it, and each one has a different light up. I'm going to show you the back, the open piece. And so everything's connected together. As you can see, it's kind of a little mess with the battery pack right down there. Kind of fun, kind of cool. Grateful that I got to do it. Let me know what you guys think. But thank you.
The project was create a glove that would be able to, in like a Nerf gun war sort of scenario, track your ammo and your kills as you're in the game. And working on the glove, we deviated a lot from the inspiration and made a much more simplified design of something that could be more easily used in real life. Like the battery pack is kind of tucked on an armband up the arm, and all of the decorations on the glove are pretty much taken off, with the exception of the things that were necessary to the functionality of the glove.
So this is the first of 3 modes on the glove and the first of 2 counters. This first counter is meant to count up. It's more for something like scorekeeping or shots fired. So you press this first button and it'll actually add a light onto the counter. And if you press the second button, then it will retract a light from the counter. If you go all the way out, you know which mode you're in because of these finger lights. When this first light is on, you know that it's in the first mode. And when you press both of the buttons at the same time, it moves into the down counter, and that lights up the second light to let you know you're in the second mode. This one has the same controls as the other one. You just press the second button to go down and this first button to go up, but this one will start all the way full so that you can count down instead of up. This would be for like keeping count of your lives or your ammo. Another useful feature is that you can keep pressing this button once it reaches the edge, and it will not add any more numbers into the software. So if you keep pressing this button, it's okay that you can press the second button and it will just immediately count down afterwards. The third mode that it has is if you press this button on the side here, it will actually switch into a third mode, and this is a game accurate mode. The glove is based off of a gravity glove from Half-Life Alyx, and so this display is a little bit more realistic. So this mode actually imitates all of the functions of the gravity gloves. You can see how it's got the screen that looks more like the gravity gloves. It's got the lives on the top and the ammo on the bottom. And the other purpose of the gloves in the game is to grab things from far away. So you actually see that if you point up, it turns on the lights as it would in the game as if you had selected something to grab. So if you point it back down and you deselect, you can point it back up and you can reselect the object. And then if you were to bring it all the way back, that would imitate grabbing something from far away, and it will play that little animation to show that you've grabbed something.
Hello, my name is Jackson Peterson, and for my final project for digital making, I made this stuffed Darth Vader toy. I made it with the intent of, like, if you have a child or someone who is like a Star Wars fan and needs like stimulation or like something to entertain them, this is it for you. So the way that it works is the battery pack back here, you turn it on, and when you shake it, its lights turn red down here on the circuit board. And then if you press that button, his lights turn on. And if you press this top button, it plays his theme song. And when you want to turn it off and start over, you can press both buttons at the same time. And it will turn off again, and then everything goes back to doing it again. So, yeah, that's my project. Thank you for watching.
Hi everyone, my name is Nicole, and for my final project this semester, I made something that I call the Nighttime Anxiety Bunny. So I made this bunny to help solve the problem of nighttime anxiety or general anxiety in children. This is something that I struggled a lot with growing up, and I remember always having a stuffed animal to comfort me. So I wanted to incorporate a stuffed animal in my project while also adding features that will help anxiety. So the first feature I have the battery pack on the back. If you turn it on, it turns into a night light. So I have this and it keeps glowing until you turn it off. So I figured if a kid is scared of the dark, they can turn this on and it can have a little light to comfort them. It also has another feature. I made this little sign on his hand. It says "Shake Me." So if you shake the bunny, it starts playing "Twinkle Twinkle Little Star," and I figured that this is also a comforting feature if there was a kid having a ton of anxiety at night. So yeah, I hope that this project can help anxiety in children and that it can make a difference.
For my project, I made a Scratch extension that adds a few new blocks to Scratch that allow you to integrate the Wii Remote into your Scratch projects. So I've made here an example project, so when I click the green flag, you'll see on the Wii Remote the lights light up and I can move around on the screen. With the arrow keys, you can go and collect all the apples. The Wii Remote vibrates when I touch the bat and I lose a life down at the bottom. That's what the lights represent in this example. And then if I lose all the lives, then the game is over and the lights are all off. The way that I did it is with a server that I wrote in JavaScript that is running, and every frame Scratch sends a request to the server, and the server sends back a list of all of the buttons that are currently being pressed so that Scratch knows which buttons are being pressed and can use them in the project.
Hi, my name's Cade Furman. For my project, I decided to make a simulated dice, and this is what it looks like. And I made this because if you've ever played a board game before, you know that it's very easy for a dice to roll too far away when you roll it or to roll off the table, and it can often just be inconvenient when things like this happen. So I decided to come up with this dice design, and the way that it works is I have the Circuit Playground device in here on the inside, and I have some LED lights threaded with conductive thread up on the top. And it is shake powered, so when you shake this device, it makes a little noise and randomly chooses a number 1 through 6, and depending on the number that's chosen, it is supposed to display the corresponding number of LED lights at the top, like that. So unfortunately with mine, only these 2 out of the 6 lights at the top work, because I think I had some problems with the threading, but that's the idea, is that it would choose a number 1 through 6 and display those lights at the top. And so I thought this was fun because it keeps the same fun of shaking a dice while you're playing a game, but it eliminates the risk of losing the dice or having it fall off the table and things like that. So I was disappointed that all the lights didn't work the way I intended, but I had fun designing it and coming up with it, and I think that it turned out okay.
Hey, hi everyone. Welcome to this presentation. So in this presentation, I'll be walking you through my final project, which I worked on as a part of the digital making course. So essentially, a lot of these digital apps which are available these days to teach children coding can't be used in the classroom because of this policy. So instead of those apps, these days we have many different products in market, such as these robots which move on the floor based on the sequence of tiles which you place on this grid. So for instance, if you place these colored tiles, each of these color basically signify a movement. So once you complete the sequence of the tiles and you press this blue button, this bot will start moving on the floor, and that's how children are basically taught programming. This is an illustrative representation of the same. So for instance, if you want to make your bot move from square D2 to square D4, you basically place 2 green tiles which signify the forward movement, and then you press this blue button and the bot will move from this space to this space. So often, like, associating the symbols with that of the movement is something which children find it challenging. And so as a part of another research project where I was involved, I observed that the facilitator engages children in some intermediate activities to establish this connection. For example, the facilitator would draw tiles and let children perform the movement with their own body based on the drawn tile. So if there would be a green tile which represent forward movement, the children would take 1 step forward. If it's a black tile, the children would take 1 step backward, and so on and so forth. So inspired by this pedagogical activity, I thought of like designing another interactive interface, which children can basically play with, and that is likely to help establish this symbol movement connection. I thought of designing this interface in which you walk with your Pokemon to find food, and you can see like this is the circuit playground, and it already has like 10 NeoPixel LEDs on top of it. And I also use MPU 6050 sensor to detect like movement. And so basically, based on the type of movement, if it's like forward or backward or left turn or right turn, these LEDs will light up. To just give an example of how this can be instantiated in the classroom, so imagine the task is to traverse this path to make your Pokemon find food on this square. So you have to like go 2 steps forward, then 1 step backward, then you take a right turn, and then again take 2 steps forward. So the way the interface would work is if you take a forward step, it will light up the red LED. So again forward, so second red LED. If you take backward, then green. Then you take right turn, yellow, and 2 steps forward and you reach your food. So again 2 red. So essentially these movements can now be thought of as colors, and the facilitator could design these cards, the path cards, which are coded, and the task for children would be to like decode the path to find the food for the Pokemon. This is a brief demo to illustrate the same. This is a partially functional prototype. Okay, so there's forward movement, so it red, so backward is green. So again, if you go forward, it red, turns red, and backward it's green. So I'm yet to implement the left rotation and right rotation in the future version. But yeah, this was essentially the idea. Thanks a lot for patiently listening. And if you have any feedback and comments, please do reach out to me. Thank you.
Hello, everybody. So this is my final project that I made for this course. I originally wanted to make a night light slash kind of like happy light or productivity light, but I ended up taking a different route. So instead, I made a 3D shadow box slash night light. So the problem that I set out and wanted to address is mainly for kids who are afraid of the dark and like some sort of nightlight. They find like comfort in it, and just overall have something by their bedside that can kind of keep them company during the night. So really the emotion and the need that I wanted to get out of this was just a feeling of comfort, and feeling like everything's going to be all right during the night, so you don't have to be worried about the dark or anything like that. So yeah, I wanted to make this shadow box. So real quickly, I just wanted to kind of demo this. So I made some silhouette cutouts, and I made this box. So I made a 3-layer box to give it some depth and some levels to it. So we've got some forest background, some trees, a bird, and then a person walking in the forest. So you can see I've kind of detailed those elements to it, and then I've added the actual simple circuit in the background with a couple LED lights as well, to kind of give it some more effect. And then with the piece, whenever the user claps their hands, it will change lights and then play a little song. So I did Old MacDonald Has a Farm, but yeah, they can really code it to do any song that they want to do. But yeah, just something kind of cool that the user could put by his or her bedside, and just kind of keep them comfort during the night. So yeah, thank you guys so much.
Thank you so much for watching. Have a good day.